Hello, my dear students. Raman Rana here, mathematics teacher, Cambridge International School, Dasua. Today, we will carry on our topic vectors. So yesterday, we have discussed vectors. Our first topic was with translation of vectors. We have studied that the component x component and y component towards right hand side if a vector AB is 3 5, so 3 from any point here we will move 1 2 3 towards right hand side and 5 towards y axis. Then after translation of vectors, we have studied the addition and the subtraction of vectors. We have also gone through the negative of a vector. If a vector AB is a vector, we also represent a vector with the small letter a. If vector a is 3 5, then minus of a vector a means negative of a vector is minus 3 minus 5. So today we will start with the next topic, that is magnitude of vector. Before magnitude of the vector, we have also discussed that multiplication of a vector by a scalar. Multiplication of vector, suppose A is a vector 3 5. If this vector is half, then we are writing this vector as 1 by 2 of A or 1 by 2 of vector AB, half of AB. If you want to go with the multiplication 2 times, if twice of AB, it will be 2 into 3 6, 2 into 5 is 10. So we will write here twice of AB, means this vector will be the new vector 2AB is twice of AB. If you are going for the multiplication with 3, then 3 times the vector. And negative of a vector, then the length of the vector remains same, the direction will change. So today we will start with the topic, that magnitude of the vector. So here I have a square grid also to represent the magnitude of the vector, magnitude of a vector. If a vector A is equal to, just take the components are 3 4. First is translation vector. If A is the point here and 3 units 1 2 3 and 4 units upward 1 2 3 4, so this is the vector A. So what is the magnitude? Magnitude means size. Magnitude means size of the vector, size. And how the size of the vector is determined? Size of the vector is determined by its length. So we represent the magnitude of the vector in this form, like modulus. This is the magnitude of vector A. Or we will write magnitude, if AB is a vector, then we will write this is called magnitude of the vector AB. So here, how to go for the magnitude of vector A? That is always equal to under root 3 square plus 4 square. So here we are applying Pythagoras theorem. we are applying the Pythagoras theorem to find the magnitude of a vector. We can take one more example. Here it is A, B. We can take one more example. If we have a vector B is equal to -6 and 8. B is -6 and 8. So what is the magnitude of B? Magnitude of B is equal to here minus of 6 whole square plus 8 whole square. Square of a negative number is also positive. Magnitude of A, it was 9 plus 16 is equal to under root 25, which is 5. So here the magnitude of A here is 5 units. So magnitude of A is what? 5. And the magnitude of B here is 36 plus 64 is equal to 100, and under root 100 is 10. So the magnitude of this vector B is 10. So here we can find the magnitude of any vector in our textbook. Two exercises, exercise 31.4 is based on your magnitude of the vectors, whereas exercise 31.3, this is also very general your exercise based on the addition and the subtraction of vectors. Let's take again a few examples of your addition and subtraction. If I have a vector A is like 1 and 2, and B is a vector here, B is a vector like 3 minus 1. So we will check in both cases, if A plus B and B plus A, what will be the result? One is A plus B, we will check, and another we will go for B plus A. After going for these addition, we will check whether the result is same or not. So many questions we have in these two exercises based on your addition and subtraction of vectors. Let's start with A vector. X component is here. Let's take the same square grid here. Now let A is the vector. A is 1 here and B is 2. So this is the vector A here. Arrow shows the direction. This is vector A from this point to this point. Now B is 3, 1, 2, 3, and Y is minus 1. So Y is minus 1 here. X component 3, 1, 2, 3, and Y is 1. So this vector here is vector B. Will denote vector B here. So from initial position to final position, this vector here, when we join these two ends, initial and the final, we will get the vector, this vector from A to B. This vector, direction of this vector is from A plus B. This vector is A plus vector B here. So if I am naming it as A, B, C, so I will write here A plus B, that A B vector plus BC vector is equal to your AC vector. The sum of two vectors is AC. Now let's check. We want to start with B plus C. B plus A. Now it is very important that vector B is 3 minus 1. So here this is a vector 3 minus 1. We can represent it anywhere. If I am representing from this point, so 3, 1, 2, 3 and minus 1. So this vector is from here is a B vector. This vector is again if 1, 2, 3, 1. This vector is a vector B. We can represent vector anywhere. Its magnitude and directions remain the same. So here we have gone through A plus B vector. A vector plus B vector is equal to AC vector. Initial position is here and final is here. Now we are going for B vector plus A vector. So let's take here, like this is from here B vector is B here is B is here 3 minus 1, 3 minus 1. So 3 minus 1, this is a vector B here. This vector is vector B here. Now A vector, this is the initial position. Now we want to add A in it. A vector is 1 and 2. 1 and 2. This vector is here called vector A. This is called vector A. Same direction here, and magnitude is also same. So here vector B plus A, initial position and now final position. So we will join both these points, and this vector is called B plus A vector, and direction is from this side. And see, if we start from here, this is vector B, this is vector A, and now the straight line distance from this initial to final, this is called vector B plus vector A. A new vector is formed, which is vector called vector A, B plus A. So here these two are different, A plus B, and it is not only the magnitude, it is related with the directions also. So I hope you got the addition, subtraction of the vectors and the magnitude of the vectors. In magnitude of the vectors is, as I have discussed, we are talking about the size of the vectors, means length of the vectors. So dear students, today you can go for these two exercises, exercise 31.3 and 31.4. So we have left only the one topic, that is your vector geometry. In that various figures we will apply these concepts of addition, subtraction of vectors, negative of a vector, and magnitude of the vectors, and we will solve the various questions by applying the knowledge of the vectors. With this, thank you very much. Stay safe, stay healthy, and stay home.